Alrighty, welcome to IET 301, Engineering Project Cost Analysis. In this lesson, we'll be reviewing Chapter 1 real quick. This should be a very nice and short lesson. Our objectives for this lesson are to introduce engineering economics, introduce the scope of problems that we'll encounter, the decision-making process that we'll use, and we'll provide a very quick introduction to engineering ethics. Essentially, we're just going to describe what the Association of Professional Engineers define as ethics and how they evaluate them. Okay, so Chapter 2 introduces the decision-making process. Decision-making process and you'll have to forgive me, as you'll notice throughout the course, my spelling is not as good as it should be. For example, you will periodically see me misspell words that I probably simply should not misspell, so just bear with me there. Keep in mind that I am an engineer, not English major, so hopefully that doesn't frighten anyone away from the course. So in the decision-making process, what we need to do is develop a rational approach to develop or choose, I should say choose, a worthwhile solution to the problem. And as the name suggests, in our case, we're going to be going through and analyzing economic problems and hopefully coming up with good solutions to these economic type of problems. So there are three basic types of problems, and this will be very evident to us. Types of problems. Keep in mind this is Chapter 1, so we break it down very rudimentary. There are simple type of problems. These are essentially problems that can be thought through in our head. I'll say worked in our head. They are the simplest form of problems. And one example might be, do we use cash for a purchase or credit? The typical person will look at that statement and say, well, it makes sense to use cash whenever you can because we know that using credit unnecessarily is not a good idea. So very seldom will we apply our decision-making process or our engineering economics that we learn in this course to these simple types of problems. These are typically something that we can answer without any kind of sophisticated analysis of the problem. The second type is problems is the intermediate problem. This is not necessarily a super complex problem, but it requires some type of system to analyze. So more complicated, and requires analysis. This is the most typical problem that you'll encounter in engineering economics. Okay, And an example of this would be what equipment should be purchased for a production line. Okay, we can see that that is obviously going to require a level of analysis that we simply cannot work in our head. It's going to take or have to take into account different scenarios, and therefore this is representative of the intermediate type of problem. The final type of problem, which is largely outside the scope of engineering economics, are the complex problems. Okay, these complex problems are or tend to be not only economic in nature, but also humanistic or political, or also have humanistic or political considerations. One such example of this would be the choice of moving production from one plant to another as a production plant to another. While this may not have any political issues, it has humanistic issues that need to be taken into account. For example, will this involve a layoff? If so, how many people will be affected by this layoff? Is it going to significantly affect the local economy near that plant? So these type of things are all involved in these complex problems. When we're dealing with these complex problems, we generally limit the scope just to the economic considerations. So we can apply engineering economics to the economic considerations of that complex problems, but we tend to segregate or analyze the humanistic and political considerations separate from that. Not all economic decisions necessarily are good decisions because they have very adverse humanistic and political consequences go along with them. Okay, so any problem that we apply engineering economic analysis to should meet 3 criteria. Okay, so I should probably say problems in engineering economics should be, okay, first thing is important enough to justify the effort. We probably would not go through and analyze an economic type of problem unless it had some value. It was important to our department that we're supporting or some other aspect of our position. It needs to be complex enough to justify analysis. keep in mind, this just means that we need to be, there should be more to it than just thinking through the solution. We should have to develop an analysis process in order to get the job done. And this analysis process should be complex enough to make it worthwhile. And finally, as would make sense, the problem should be economic in nature. Since this is engineering economics and we're trying to apply the principles in this book to engineering economic problems, the problems that we address should be economic in nature. Okay, so the decision-making process that we'll use is essentially a 9-step process. You'll notice that if you're familiar with the scientific method, this process follows some of the same conventions. So first thing we have to do is identify the problem. The book actually says recognize the problem. And there are 2 ways that problems are typically recognized. Okay. Most corporations will have some form of total quality management in place. This is otherwise known as TQM. This total quality management is just a way that they can go through and review a process or a product or production line and determine if a problem is in play, is present, and if so, they can recognize the problem and follow through the rest of the decision-making process to address that problem. The other is continuous process improvement. Or CPI. Again, these are just ways that we can identify problems in a production environment or in some type of environment and recognize the problem and move through the solution process. Okay, second thing that we need to do in the decision-making process after we recognize the problem is to define our goals. If we're losing money, we're going to want to recover that money or reduce expenses. If we identify that our profits aren't large enough or we have poor inventory control, we're going to want to go through and define those goals to address the problem that's been recognized. Step number 3, we're going to assemble irrelevant data. Get all the data together so we can take a look at it, identify feasible alternatives, this will give us a direction to go, and we can evaluate each of these alternatives to determine which is the most useful or most practical. 5, we're going to select the criteria. That defines success. Six, we'll construct a model. This right here is where we typically get involved with the economic tools that we'll learn in this course. When we go through and construct the model, we'll be using our different present value or future value equations to construct that model in order to analyze the problem. 7, we go through and predict the outcomes so that we know what to expect. Step number 8 is choose the best alternative. And finally, step number 9 is audit the results. See how we did in the decision-making process. Okay, so this just sets us up with a template that we can use when we're going through a decision-making process. Of course, there are instances where everyone is guilty of not necessarily going through each of the steps, but if you go through and recognize the problem, define the goals, follow through this process, it really helps build a pattern in your decision-making process, which can help you in the long run. Okay. The last thing that Chapter 1 introduces to you is engineering ethics. For those of you that are planning on taking the Fundamental of Engineering exam, that leads to your EIT license. This is a very, very good place to spend a little bit of time. There are 6 or 7 questions on the FE exam that specifically relate to engineering ethics. And if you know and understand these principles that are listed in the Code of Ethics, these will be very, very easy points to pick up. So the Code of Ethics as stated by the National Society of Professional Engineers, state that an engineer will hold paramount the safety, health, and welfare of the public. What you will notice as you review the Code of Ethics is that it is very, very similar to the Hippocratic Oath that medical doctors and the medical profession must adhere to in their practice. We are professionals just as medical doctors are, and therefore we have a very similar Code of Ethics as you'll see in the medical profession. Second thing that an engineer must do is perform services only in the areas of their competence. Just like in the medical area, you would not want a neurosurgeon performing heart surgery on you. Much is the same here. I, as an electrical engineer, would not take in a job that involves civil engineering tasks. A civil engineer should not take on mechanical engineering tasks, so on and so forth. You should restrict your services to those areas that you are licensed in and that you're competent in. Okay? An engineer will not issue public statements or shall only issue public statements in an objective and truthful manner. That means that unlike a entertainer, we cannot go out and advocate for a particular device or product if there is not, or if that advocacy is not objective and truthful. We could not go out and say that an iPod is the best MP player on the planet. All we could do is provide a objective and truthful statement pertaining to that device. Okay, an engineer must act for each employer client faithfully, okay. One of the more common problems you'll see on the FE exam is that of moonlighting. Moonlighting typically is allowed, or is sometimes allowed by engineers, but it is an unethical behavior because your services then tend to compete at a discounted rate against other engineers that are trying to run their businesses for profit. And therefore, those moonlighting activities provides you an unfair advantage that the other engineers in that job sector do not have. An engineer must avoid deceptive acts. Okay. And an engineer must conduct themselves honorably. Responsibly and ethically. At all times. Okay, so with this, we are done with our introduction of Chapter 1. You will see that much like many other first chapters in the textbook, it provides a real general, low-level introduction to the topic. The Chapter 1 quiz is available. Please make sure you're doing it. As of right now, we only have 5 people that have taken that quiz. Make sure you're not getting behind in this class. Ultimately, because it's online, nothing is due until the 22nd of August. However, you should be steadily working through the content in the class rather than trying to hammer it all out in 1 or 2 weeks. So with that, if you have any questions, please feel free to contact me. You can either email me, my contact information is on Canvas, or you can give me a call. I do prefer emails. Thank you.